Hey everyone, and welcome to this explainer. Whether you're grinding away for your CCNA, studying cybersecurity, or you're a developer trying to keep your servers humming, mastering network fundamentals is absolutely crucial. Today, we're zeroing in on a massive piece of the puzzle, Layer 5 of the OSI model, otherwise known as the session layer. We're going to start with a really intuitive breakdown, then we'll get into the technical nitty-gritty, and finally, we'll wrap up with some real-world examples so this actually sticks in your brain. But first, picture this. You're downloading a massive 10-gigabyte file. Maybe it's a huge software update. Suddenly, boom, your Wi-Fi drops for a split second. Absolute panic sets in, right? You think you just lost hours of progress. But then the connection kicks back in, and the download resumes right at 80%. It doesn't start over from zero. You breathe a huge sigh of relief. But how on earth does your computer know exactly where it left off? Well, the unsung hero working tirelessly behind the scenes there, that's the session layer. Okay, let's dive right in. Here's a quick roadmap for our explainer today. We're looking at the OSI model and Layer 5's place in it. Then we'll break down the core session logic. After that, we'll get into the technical processes, talk about web and security applications, and finish up with some real-world examples. All right, Section 1, the OSI model and Layer 5. Let's figure out exactly where we are in the network stack. So when data travels from your screen to a server, it flows through these 7 layers in a process we call encapsulation. Now look right in the middle at Layer 5. It sits snugly between the presentation layer, which handles all that data formatting and encryption, and the transport layer, which takes care of the actual physical delivery. Layer 5 is the bridge. It organizes the communication. It's incredibly important to realize that Layer 6 above it and Layer 4 below it rely entirely on Layer 5 to keep their processes organized. Without Layer 5 keeping the conversation glued together, the data formatting just fails, and the delivery has zero context. Moving on to Section 2, what exactly is session logic? We know where it lives, so let's get into what a session actually means in plain English. Honestly, the absolute easiest way to wrap your head around this session layer is to just imagine making a phone call. You dial a number, someone picks up, they say hello, and boom, a logical space for a conversation is created. You both know you're talking to each other, you filter out the background noise, you take turns speaking, and then when you finally say goodbye and hang up, the conversation is officially over. A session is really just the digital version of that. It's the organization of a conversation between two systems. Now, if you're taking IT or CCNA exams, you need the strict technical definition. A session is not the raw data itself, and it's definitely not the physical cable plugged into your wall. It is the logical communication process that is established, managed, synchronized, and terminated between two devices or applications. That's the boundary. It's not about how the data physically travels, it's entirely about organizing the timeline of that interaction. We can actually break this down into 3 core steps. First up, session establishment. Think of this like logging into a secure system. Second is session maintenance, where the system actively keeps the connection alive and manages the flow of data while you do your work. And third is session termination, basically when you hit log out. And hey, that last step, it is absolutely critical. When a session terminates, the system securely frees up memory and processing power. If we didn't have proper termination, servers would just hemorrhage resources and crash from memory overload in no time. All right, Section 3, technical processes and synchronization. Let's lift the hood and look at the actual routing logic making this all happen. Remember that massive 10-gigabyte file download we talked about earlier? Well, here is exactly how that works. The session layer uses a synchronization process to create checkpoints, essentially save points, during really large data transfers. So imagine the session layer drops a sync marker every 100 megabytes during your download. If your connection completely drops at 850 megabytes, the system doesn't freak out. When it reconnects, it just asks the session layer for the last acknowledged checkpoint, which would be 800 megabytes, and it flawlessly resumes the transfer from right there. It saves a massive amount of time and bandwidth. Pretty clever, right? Now let's talk about dialogue control, which is how the session layer dictates the rules of engagement for the devices. It can enforce half-duplex communication, which operates exactly like a walkie-talkie. You have to press the button to speak, and while you're talking, the other person can only listen. Only one side sends data at a time. On the flip side, it can allow full-duplex communication. That's like a standard phone call where both devices can send and receive data at the exact same time without talking over each other. Now, here is a massive sticking point that trips up so many students on exams, knowing the difference between the transport layer and the session layer. Think of the transport layer as the delivery truck hauling TCP or UDP packets down the highway. That truck driver, they do not care if the boxes are for a wedding or a funeral. Their only job is delivery. The session layer, on the other hand, is the event manager sitting in the office. They decide when the event starts, they track who is talking to who, and they decide when the whole thing finally wraps up. Moving into Section 4, Web Sessions and Security. Let's see how all this networking theory actually applies to modern web apps and cybersecurity, because this is where the theory gets incredibly practical. If you dabble in web development, you've probably heard the terms stateful and stateless. A traditional web login is stateful. The server creates a session, holds it in memory, and specifically remembers you as you click around from page to page. But REST APIs, they are almost always stateless. Imagine a REST API like a server with total short-term memory loss. Every single request is treated like a brand new interaction, totally separate from the last one. That means you have to send your credentials with every single request because the server forgets who you are the second it replies. So to make a stateful system actually work, the server assigns you what's called a session ID. This is a highly complex, totally unique identifier that links you to your ongoing activities. And absolute uniqueness here is non-negotiable. Think about it. If a server accidentally gave you and another user the exact same session ID, or if a hacker could easily guess the next number in the sequence, you could literally refresh your page and suddenly find yourself looking at a total stranger's private dashboard. Not good. So, how are modern developers actually managing these IDs? Traditionally, they're securely stored in your browser as cookies and kept in the server's backend memory. But the web has evolved. Nowadays, engineers often use JWTs, or JSON Web Tokens. These securely package up your identity and pass it back and forth without bogging down the server's memory. And for massive global platforms handling millions of users, developers use tools like Redis, which is a blazing fast memory cache that handles millions of active sessions all at once, literally at lightning speed. But of course, where there's a valuable ID, there is an attacker trying to exploit it. You've got to understand the difference between two major threats here. First is session hijacking. This is where an attacker intercepts your active session ID while you're using it. They basically steal your keys. Once they have it, they can perfectly impersonate you to the server. Then there's session fixation, which is kind of the reverse. The attacker tricks you into logging in with an ID they already control. It's literally like them handing you a bugged key, waiting for you to unlock the door, and then just walking right in behind you. To fight back against this, engineers have to build some really strict defenses. HTTPS is step one. It encrypts the traffic so your ID can't be read while it's traveling over the network. Then you have the HTTP-only flag on your cookie. That is like locking your session ID in a glass vault. Your browser can send it to the server, but malicious JavaScript running on the page can't reach in and grab it. And the secure flag makes sure it only travels over encrypted connections. But honestly, a strict session timeout is your absolute best friend. Automatically logging out idle sessions shrinks the window of opportunity for an attacker to almost zero. And that brings us to Section 5, real-world practical examples. Let's brilliantly illustrate how this theory ties into things you do every single day. Have you ever loaded up an online shopping cart, accidentally closed the browser tab, totally panicked, reopened it, and realized, phew, your items are still there? That is the session layer maintaining your state. It's the exact same logic that keeps your audio and video perfectly in sync during a chaotic Zoom call. And it's what ensures you don't instantly get booted from a multiplayer game just because your ping spiked for a half second. The session holds the underlying logic together even when the physical network gets a little wobbly. Honestly, the absolute perfect real-world metaphor for the complete session lifecycle is an ATM. Think about it. You walk up, insert your card, and punch in your PIN. That securely establishes the session. Once you're in, you check your balance or withdraw cash. That maintains the session. And finally, when you're done, the machine ejects your card, definitively terminating the session. It guarantees that the person standing right in line behind you can't just walk up and access your bank account. So, to wrap up the incredible value of Layer 5, think of it like this. Without it, modern networks are just blasting disjointed packets of data blindly into the void. The session layer is the intelligent manager that turns that chaotic stream of packets into a continuous, manageable, and highly secure conversation. We have covered a ton of ground today, from basic walkie-talkie analogies all the way to deep web security protocols. But I want to leave you with a thought that connects this networking theory directly to your own habits. The next time you're working in a crowded coffee shop and you walk away from your laptop without hitting logout, ask yourself, is your session ID truly safe from hijacking? Thanks so much for joining me for this explainer. Stay secure out there and keep exploring the amazing world of networks.